Welcome everyone. This is the session 2 from the playlist of rotational motion, and the topic for the today's session is center of mass. So here I have written three bullet points which will briefly describe the center of mass. Now the center of mass is the point where all the mass of an object is concentrated. This is the first definition, and the second important definition is that it is the point where the force applied results in the linear acceleration without any angular acceleration. Third point is, if a body consists of n particles of masses, say m1, m2, m3 and so on, along a straight line. So here I have considered that straight line to be the x-axis, that is say x-axis. Then the center of mass of this system of particle along the x-axis is given by, that is, it is the product of this m1, x1, m2, x2, m3, xn and so on, that is up to mn xn divided by m1 plus m2 plus m3 and up to mn, where here x1, x2 and x3, these are the distance of the particles from the origin. So this x1 is the distance of the say particle from the origin having a mass m1. Similarly, x2 is the distance of another particle of having a mass m2 from the origin and so on. So this center of mass x can also be written as summation of, that is mi xi divided by m, because m1 plus m2 plus m3, this is equal to the mass of the body. So here I have written it here as m, and this will be the summation of mi xi divided by m, where I is from 1 to n. So here this system consists of these n particles, and so we have calculated the center of mass of this system of particles along the x-axis. Now similarly, now any particle, an object is made up of number of particles, and each particle can have the x, y and z coordinates. So along the x-axis the center of mass is given by this formula, and along the y-axis the same, we can get the center of mass, let us say it is y, this will be equal to sigma, this will be equal to mi yi divided by m. Or we can also write this equation as y is equal to m1 y1 plus m2 y2 plus m3 y3 plus mn yn divided by m1 plus m2 plus m3, m1 plus m2 plus m3 plus m4 mn. So here y is the center of mass of this system of particles along the y-axis, and here y1, y2, y3 and yn, these are the distances of the particles from the origin along the y-axis. So here this xi, this x1, x2 and x3, these were the distance of the particle from the origin along the x-axis. This is along the x-axis. And here in this case, the center of mass of this system of particles consisting of n particles is equal to m1 y1 plus m2 y2 and so on, divided by m1 plus m2 plus m3 up to mn, and this can also be written as summation, that is mi yi divided by m, where I is from I to n. So this is the center of mass of a system of particles consisting of n particles, and this is the center of mass of a system of particles along the y-axis, and here y1, y2, y3 and so on. These are the distances of the you can say the individual particles from the origin along the y-axis. So similarly we can also calculate, or you can also write the center of mass of this system of particles consisting of n particles along this z-axis as sigma. This is equal to m I zi divided by m. Okay, or this can also be written as z is equal to m1 z1 plus m2 z2 plus m3 z3 and so on up to mn zn. Okay, this is divided by m1 plus m2 plus m3 plus mn. So this is the center of mass of a system of particles consisting of n particles along the z-axis, and here z1, z2, z3. These are the distances of the particles, of the individual particles from the origin along the z-axis. So we can say that this is the center of mass of a system of particles, or you can say the center of mass of any object, okay, can be defined as, that is center of mass of a system of particles can be defined as sigma, that is equal to mi xi divided by m mi yi divided by m and sigma I to n, sorry, from I is equal to 1 to n, which is equal to m I zi divided by m. So the center of mass of a system of particles can now be defined as this summation, that is mi xi upon m. I is from 1 to n. Similarly, this now this is the center of mass of a system of particles along the x-axis. This is the center of mass of a system of particles along the y-axis, and this is the center of mass of a system of particles along the z-axis. So, so in this way, we can find the center of mass of a system of particles along the three coordinates. Because see, any object, you can just take any object. For example, let's consider that we have a sphere. Now, each and every particle in a sphere will be consisting of three coordinates. So, the center of mass of that particular object will also have these means it will have three values along the this x direction, along the y direction, and along the z direction. So thank you very much for joining this session, and in the next session I will be taking up a couple of questions from this topic, that is center of mass. So till then, have a nice day. Bye.